All right. Welcome back. Let's see. Right. Yeah, today is the last lecture where we are covering the architecture that we've been building, the client server application that we've been working on for the last several months, right? We said that we were working on building a web application where we were following the client server application architecture, where the client side, right, made the part of the user interface that interacted with the user, received all the events from clicking, dragging, typing at the keyboard, right? And then displayed a user interface that reacted to the user input. But then then we kind of then switched over to the server side, right, halfway through the course, and where we were able to do a lot of the things that we couldn't do in the front end, right? We integrated the front end so that it could delegate a lot of the work to a server, right, that executed outside of a browser, did not have the limitations of the browser, right, and then integrated with the database for permanent storage. So today is the culmination of that technology stack, right, where we got to talk a few other things about uh, implementing the database, right, the permanent storage solution, right, we're using MongoDB, a non-relational database. So we'll be talking about some of the strategies of and how to structure data depending on the types of relationships that you might want to implement, one to many, many to many, and so on. So today is the culmination of that technology stack, and and also the culmination of the last assignment, right? The A6 assignment, which focuses on the database, right? Implementing the non-relational uh, permanent storage solution, right? That we're adding to our application, right? In the next several lectures, right, we're going to be discussing more advanced topics on how to integrate this application with third-party APIs, and also how to embed artificial intelligence tools such as ChatGPT uh, into our application. How can we enhance our application with very very useful AI support for natural language parsing, image understanding, generating images, and translations, coding, right? So we'll implementing simple chat bots, right, with that we can embed inside of our application and generate AI generated content. So that's going to be the focus for the next couple of lectures, right? It won't be a new part of the infrastructure, nothing part of the client server application. Right? We're done with the main core content. So the next couple of lectures are going to focus more on AI and integrating with third-party APIs, and then there won't be an assignment associated with these last couple of topics that we're going to start up in the next lecture, right? So because we are coming towards the end of the semester, right? So you should be focusing a lot of your effort towards the project, the final project, and perhaps you've already have a prototype, perhaps an MVP implementation that already has a user interface, perhaps some state management on the front end, even perhaps some API implementations on a server. Maybe you haven't done the database quite yet, but definitely don't leave all the effort for the project uh, till the end, right? So please make an effort to work on it every day if you can, right? And collaborating with your team. So yeah, so the next uh, couple weeks are going to be there's no assignment, but yeah, no, definitely make sure to make progress towards completing completing the final project, right? That's it'll be due towards the 20th, right? The that last week of lecture, and then the week after that, the week after the project is due, there will be a week of grading where You're going to be demoing your projects to TAs or myself, right? And we will be going through the requirements of whatever it is that you built, right? If you went and implemented the Piazza clone, or if you added the quizzes implementation to the Canvas application, right? Or if you implemented something entirely on your own, right? There are some requirements that we went through. So the TAs and myself, we're going to go through those requirements and ask you to demonstrate that whatever it is that you built, right, matches those requirements. So yeah, so make sure that you're working towards completing that. So yeah, so the very last week before the grades are due, right? It's going to be all demos, right? A demos week. So the TAs are going to share with you soon a spreadsheet where you can register for those demos, right? They'll provide some time slots where the team can register, and then you'll all meet that particular time slot to demo your project. Okay. So anyway, so that's the plan for the next couple of weeks, right? As we are reaching the towards the tail end of our course. Okay. All right. Okay. So the last time we met, right? We discussed using a database, implementing a database, and we discussed how to implement the user management, right? Being able to create users, delete users, log in, and things like that. And so we discussed how to create schemas and models and all sorts of operations, right, to manage users. And so today we're gonna keep going, right, discussing uh, more how to apply this database that we learned about how to create models and schemas and whatnot, right? But in this time around, we're going to use those skills, right, to add uh, a, a persistence, right, permanent storage solutions, right, to our Canvas application, right? Our Canvas application deals with courses and modules and assignments and enrollments. So there's a lot of data structures, right, that the our application uses, right? So we're going to discuss how to we're going to get you going with that, right? The assignment walks you through a lot of the work that you need to do, and so we already demonstrated, how one of these data structures can be moved over, imported into a database, right? And then we can create schemas and models and data access objects to be able to integrate with the database, right? To be able to pull that data, right, and create the data and update the data from all the way from the user interface all the way through the server, and then finally onto the database. So that was the discussion in the last lecture. So we're gonna continue, right, but now focus on more course related or Canvas related data structures, in particular, right? Things such as courses, modules, and enrollments. And that's going to give us a chance to talk about, right, different decisions that we might need to discuss on how is it that you would implement certain data structures, right? In particular, the fact that, for instance, there is a one-to-many relationship between courses and modules, right? One course is related to many modules, right? Well, how do we capture that? Also, the fact that, for instance, there might be many to many relationships, right? For instance, the fact that one user can be enrolled in many courses, and then from the point of view of a particular user, it is related to many courses. But then from the point of view of a course, right, it is related to many users. So that's a many to many. So how do we implement that, right? There are several alternatives, right? And so we'll discuss what some of the alternatives might be. Why would you choose one versus another, right? And so we'll choose one out of several, and then we'll go and implement that and just discuss that implementation and try it out and demo and learn about right those types of data structures, how to handle those data structures from an application's point of view. Okay, so anyway, so that's the plan. Let's see, any questions so far? All right, yeah, so let's discuss the Canvas application. All right, so far, right, the our implementation is it's a React application running on a Node.js server listening at 5173, right? That's a React application that is being hosted by this Node.js server, and it connects to an HTTP server, right? For interacting with its data, right? So we did find some limitations on what you can do just with the user interface, right? That's why we're integrating with a server that doesn't have those limitations from the browser, right? And can connect to a database and so on, right? But we integrate, for the user interface with the server. So for instance, here when we refresh and load the server, right? The client is going out to a server, right? And sending all these requests out, right, to the server. For instance, it's asking, hey, is anybody logged in? So it's going out to see, is there a profile, right? Has anybody authenticated with us, right? And the server's responding with 401, meaning no, nobody's logged in. I don't know who's logged in, right? So no, you can't go there. It also checks to see if it has access to courses, right? Again, it's unauthorized because we haven't identified ourselves. Okay. And now when we do identify and we say, so Ada and 123, for instance, this information is posted to the server, right? It is posted and the server comes back with a success, and we did pass our authentication, and the server responds, yep, this user does exist. Here it is. Perhaps the server should remove the password, which should not send us back the password, right? It should blank it out. We could fix that. And then the client caches this information, right, on the client in a reducer, like I think we called it the account reducers, right, where it maintains a cache, or it remembers that this is the currently logged in user, right, on the user interface, right, so that we can then navigate to different places, right, making sure that the front end remembers who's logged in, okay, without having to go out for every time to the server, right, to check, who's logged in. It also goes out to the courses, and I presume this is going out to see if uh, Ada, who's logged in, is enrolled in any courses. Presumably, she's not enrolled in any courses, so it comes back as empty. Uh, so yeah, we're logged in. We also use it to config, to confirm that we are logged in at every time that we navigate anywhere. So for instance, if I do refresh, if you remember this profile query, at first it came back with 401, but this time it didn't, right? So it's remembering, the server is remembering that we're still logged in, right? So as long as the server is running, right, the server can maintain that kind of state, right, on the server. And so on the client, right, one of the limitations that we had was that if we refreshed the screen, right, all our local state was lost, right? And there was no way for us to store anything. I guess we could have used local storage, but that's besides the point, right? So the proper place to store this ongoing state is the server. And what we're doing is that the client needs to be designed in such a way that as we are navigating, right, it should always go check with the server, right, reconstitute its state, copy it over on the client, and then as long as the state is not changing, right, then the client can go on its business within the user interface, right? But if the state changes because I'm adding a course, or I'm removing something, I'm deleting, right? Those changes are made permanently on the database, right, on the server. But then, right, we cache those results on the user interface, right, in the reducer, so that then the state can be used to render the user interface. Okay. So anyway, yeah. So we're going to continue working on this. The courses right now, the implementation is still using the old implementation of it's just using the file system, right? It's going out to the file system, looking for a JSON file, load it up in the server. That's what it's responding, right? Same thing with the enrollments, the modules, all that is still implemented, right, as a file-based implementation. So we're going to replace that, right, with what it's supposed to be, right? What it always was supposed to be is that all this data, really uh, should live in the database, right? So let's do that. Right? The current implementation for courses is that we have routes, right? We have DAOs that deal with the courses. Now we're going to learn about this in progression. First, we'll learn about courses, right? And we'll treat courses as a single data structure, right? And all the various operations that you would typically do with a single data structure, right? So courses. Well, typically you want to have all the CRUD operations for courses, create, read, update, and delete. So we'll talk about those as an individual data structure. We'll then talk about, our first type of relationship, the one-to-many relationship. So we'll talk about, that, for instance, the relationship between one course and many modules is a one-to-many relationship. One course has many modules, right? So we'll talk about that and all the CRUD operations that you would that would go along with that, right? Creating a module, but within the context of a course, right? Or if you retrieve, if you give me the course, I can give you all the modules associated to that course. So that's another way of retrieving and using that relationship between courses and modules. So one-to-many relationship, that's one of the more common types of relationships that we need to learn how to implement, right? And finally, the last big topic is the many-to-many relationship, right? How to, it's very common that you need to relate many data instances with other many data instances from different collections, from different tables, right? And there's a few ways of doing it. The more common ways is to have an additional collection or additional table who has foreign keys relationships to the other two, right? And in that case, we're going to be talking about implementing the many relationship that exists between a user and a course, right? So one user is related to many courses, right? If you ask a user what courses are you enrolled in, he says, well, I'm enrolled in CS516, all these courses. So one user, many courses. Now, if you look at it from the point of the course, you can ask the course, well, what are the users or students that are enrolled in your course? Well, these are all the students that are enrolled in my course. So so many to many, right? Many users or many students are enrolled in many courses. Can also be thought of as a two one-to-many relationships, right? So we'll talk about how to implement that. What are all the operations that you typically might need to implement to manipulate those kind of relationships, right, in a database. Okay, so that's the plan for today. Let's first start with the simplest of dealing with a single data structure or a single collection, courses. Okay, all right. So first we'll need to create a collection, courses, right, and populate it with some data. Right. So let's see. In our MongoDB Compass, right here we have a courses collection that we have already created, but it has no data. So let's populate it with some data, right? We did give you some JSON files that you can use to populate this. And for instance, let's take a look at this courses JSON. Let's see what's in here. Yes, we have an array of multiple objects, each one representing a single course, right? And each one has a primary key, right, which is a string, RS101, 102, and so on. Then we have the name of the course, we have the description, credits, and so on. All right, so we'll choose that. Let's choose this. Say import. Okay, so we have the courses imported into the database. right? Okay, so let's now take a look at interacting with this data, right? And the typical thing to do is that whenever you have a new collection, right? The recipe is that from the server's point of view, you need to have a schema, right? A Mongoose schema that describes the data structure that says that you have these fields, these are the data types, and so on, right? So the schema, then you need a model, right? That is from the schema that the model provides all the low-level functions to be able to manipulate and interact with that data structure, right? All the find, create, delete one, right? Update many, and so on, right? So all those functions, low-level functions, allow us to talk to the database. And then the next step is that we wrap those low-level functions with higher level functions, right, in a DAO, in a data access object. That's just good practice, right? That we want to shield the rest of the application from having to deal with the idiosyncrasies, right, of the particular vendor that we're using. Right now we're using MongoDB, but tomorrow we might want to use something else, right? Um, and so we might want to use Oracle. Maybe we want to use a relational database as opposed to a non-relational database, right? We want to migrate. So if as much as we can encapsulate all the low-level access to the database and provide a high-level interface, right? We can make it easier, right, for us to just modify the DAO as opposed to having to modify every small detail of interacting with the database everywhere across our source code, right? And finally, we provide the routes, right, that exposes all this data access, right, to the rest of the application, in our case, our user interface, right? So yeah, so let's do that. So let's see. On the node side, right? We're going to need, from the course's point of view, we want to interact, right? Right now, the current implementation is that our DAO is basically using, it's accessing our courses from this JSON file, right? This JavaScript file that is just loading all these courses, right? And this is the data that we see. Okay. And presumably we already have some routes, right, that allows us to retrieve all the courses. So let's try it out, right? That should be still working. So we could say, localhost 4000, and we have API courses. So that's still working. Let's just confirm that, right? If I say, if I go into my courses here and I change this to slightly, so rocket propulsion 1, 2, 3, right? If I refresh, indeed, you see that the changes is there. So we are using currently just a whole bunch of files, right? And that's where the data is coming from. Okay, so we want to replace that with getting the data from the database instead, right? So yeah, so let's do that. We'll need, first we'll need a schema, right? And so the schema is, let's see, we need to import Mongoose, right? We'll need to create the schema. Okay, sort of. Let's see my AI. Here's a schema. ID is a string, correct. We have a name, description, and I think that's it. And these are the collection where it's being stored is in courses. There we go. And we're going to export the schema. Okay, so let's review this real quick. So these are the fields that we want to interact from our database. And what we have is we have an ID, which is a string, correct, right? We have a name, which is a string. We have the description, correct, right? And if we want, we can add other things, credits. Credits is a number. We have department is a string, so department is a string, right? And feel free to add all the other fields, right? So let's keep it simple. The other thing that we need is the model. So we'll need to import Mongoose, right? We'll need to import the schema, and then we can say const the model will be Mongoose model, and this will be, I'll call it a course model, and the schema, and then we'll export the model. Perfect. Okay, so model will be the object that we can use to interact with the collection, right? We have functions such as, model dot. We have find just one record. Find by primary key. We have also delete many, delete one. So all the functions to remove, right? We have update functions. We can update individual records, right? We can create new documents into this, right? But so what we're going to do is that we're not going to implement any of that here. Instead, we're going to export it, and then from the DAO, here's where, right, we're going to replace, this database. We're going to replace that with instead using this model, right? So we'll say, we'll import the model. We'll call it, yeah, I guess the model from model. And then we're going to replace each one of these functions, right? So here we have what? Let's see. We have find all courses, right? This is going to be. I'm going to use. We're going to return model dot find. There we go. Okay. Find courses. Okay. We don't have an enrollments. We haven't worked with the enrollments just yet, so let's leave that. Let's see. We find create a course. So that's going to be what? Let's see. The course name and description that's going to come from the user interface, right? So the new course will be the course, all the information that comes from the user interface. We'll create the ID. We're not going to add it to the database. Instead, we're going to insert. We're going to say we'll say model const course will be model create new course, right? And then course new course. This will be the actual course that was inserted, right? And then we'll return that. Now this here is a this communication out to create, right? That is going out to the server. So this is an asynchronous communication, right? That goes out to a server, right? And then we want to grab that and return that. So that means that these guys need to be async, right? All these functions need to be async, and then we need to await over here. Okay. So any communication with the model that goes out and communicates with the server, right, needs to be tagged as asynchronous. So same thing here, right? This needs to be async, right? And then you can say const courses is model find. So this is await, right? And then we're going to respond with the courses. Okay. Let's see what else. So delete course. Let's see. All right. So this was going to remove the enrollments. We'll deal with the enrollments a little later. That's the many to many, right? So we're not dealing with that yet, right? We're not dealing with the one to many or the many to many, not quite yet. We're going to deal that in a bit, right? So we're not going to do any enrollments. So I'm going to remove all this, right? Right here, I'm just removing the course, right? Okay. So we'll need. So we have the course ID. This is going to be async. So this is async, and this is going to be. This will be const status. So when you use model to remove, right, it's going to delete one, right? Oh, there we go. And we're just going to return the status. So the status is a meta information, right? It's an object that captures whether the delete was successful, right? And also if was successful, then well, how many records were actually removed, right? So we're not going to handle any of that here. We're just going to return what the status was, and we'll let the user interface decide, what to display if this was an error, if it's not what we expected or something like that, right? So yeah, so it's async because we're communicating with a server. We delete one by its primary key. We're passing the ID that we want to remove, and then we will return the status. Perfect. And the update is also asynchronous, so async. And so we're not using this at all, right? So instead, what we're doing is that we're going to I say also when you update, it's also a status. So we're going to do an update one record, right? And this is the updates. So we'll say the record whose ID is course ID, right? We're going to set or update, right, with course update. So course update is going to contain the fields and the values and the new values, right, that we want to update that course. Maybe a new name or maybe a new description, credits, right, the start date, things like that, right? All that is going to be in course updates. All the fields are going to be there. Maybe not all of them, only the ones that we update perhaps, and the new values, right? The new name, the new description. So what set does, right, is that it iterates over all the fields that match, right, that you're sending me, and that match the fields in the database, and then updates, rewrites those values, right? It doesn't if you're not providing me any values for a particular field, it's not like I'm going to erase it, right? So I'm doing an update only in the fields that you give me, right? And I'll change those, right? So once I have the status, I can just return the status. Okay. All right. So there we go. So we have the data now uh, that that is now going to come from the database, right? And then once we have the DAO, now talking to the server, let's go out to the route, see if we need to change anything here. So we have get. This probably also needs to be async. So let's do async, and we'll do an await here. This also probably needs to be an async, right? And so this API is retrieving all the courses, API all courses, right? It's going to go use the DAO to find all the courses. Notice how DAO find all courses, right? It's hiding from me the fact that it's actually using MongoDB or Mongoose, right, to talk to a non-relational database, right? I could tomorrow decide to go and use some other vendor other than MongoDB. I would need to just we need to just change the implementation of the DAO. As long as everybody else just is using the DAO to interact with the data source, right? All the idiosyncrasies, the details of actually interacting with the data source, right, are hidden from me from anywhere else in the application, right? It's all encapsulated in my data access object. And finally here we'll have an await. So this is retrieving the course ID and then just removes that course. Perfect. And then here for update, again, we have an async and we have request body, blah, blah, blah. And then here we have an await. There we go. Okay. Yeah, excellent. Let's see if this actually works, right? Let's see what we need to do on the client side. Let's see, the server restarted. Let's try it out. Hopefully now the data is instead coming from the database, right? So let's refresh this. Okay, so notice that this is slightly different. It's notice that it's not coming. It didn't give me the 1, 2, 3 over here. So this gives me some confidence that this data is not coming from the file system. Instead, this is coming from the database. Let's confirm this. Let's go to the database and let's make a small change here. Right, let's put here maybe 3 to 1, and we'll do an update. Right, so I changed the name of this course. Let's refresh, right, and it didn't work. Huh? Wait a minute. Did I update? Did I refresh? Where is this? Okay, so maybe it's not going to the database. Let's see. Courses, find all courses, model, blah, 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 courses, find all courses, model, find. Where else am I using this database? Am I using it from anywhere else? Create course enrollments is using the database, right? Anybody using this? It's being used in our routes here. So let me just comment that out for now. Find courses for enrollment. Comment it out so that I can comment this out. So I have the database gone. And my server is not starting. Let's see where find all courses, yada, yada, yada. get API in my routes. So they have a still have a reference to this. There we go. Okay, so rocket propulsion. Oh, probably I'm pointing to the wrong database too. Let's see. The database that we're pointing to is Canvas SP25. Okay, Canvas SP25. Is that the database I'm using here? Oh no, I'm using CS5610 SP. Okay, so let's use the correct database. Let's point it to CS5610. Let's see, CS5610-SP25. All right, let's try that. We'll restart the server to make sure. Let's refresh. There we go. 3, 2, 1. Okay, good. Let's confirm that again. Let's make a small change here. I'll say CS5610. Update the database. Let's refresh. Okay. We are definitely connected to a database. We're retrieving the data now from the database as opposed to the file system. Okay, everybody good? All right. Okay. Yeah. So now we would want to make sure that all the various CRUD operations are still working, right? Let's see. And also want to make sure that we have since enhanced our application to be able to handle multiple users, right? Depending on who's logged in. So we would like to enhance all that, right? And make sure that now all interactions going back and forth between the user interface and our server, right, are taking into account that some folks are logged in, right, and some operations should when they're implemented, right, they should take into account, right, who is logged in, who's the current user, right. So for instance, if I create a course, uh, perhaps I might want to know, well, is this person the author of the course? Should we enroll this person, right? And who's currently logged in? That would be useful to know, to implement the logic for that. Yes. So with that in mind, right, we will need to take that into account. And we'll do that a little later when we get to enrollments and the many relationships. Right now we're just going to talk about the courses all by itself. Okay. All right, so since we are talking about the courses all by themselves, right? Let's revisit the user interface a bit, right? To use this new API that is using the is using strictly, right, the routes, right, that implements getting all the courses, getting deleting a particular course, updating a course, and that's it, right? They are working with this data structure on its own, right, regardless of people being enrolled or having modules or anything like that. So we're just talking about interacting with the courses, right? Okay, so in the front end, let's see. Right now I'm logged in. I'm logged in. Am I? I'm not. Okay, so if I go to Ada 1, 2, 3, sign in. Notice I don't see any courses. Let's for now just work with those 3 APIs, right, of being able to to do all the crudding, right, retrieving all the courses, deleting a course, updating a course, and things like that, right? So let's change that a little bit here, right? And so for instance, for the courses in the client, let's see, what do we have? Find all courses. Okay, so here we have a find all courses that can just retrieve all the courses, right? That's what we want to use. So let's use that. And right now the front end is where we retrieve the courses, which is, I believe, let's see, that's in here in Canvas where we retrieve all the courses. Yeah, right now we are using the client, find my courses. So let's change that for now so that we can deal with all the courses. Right, so we'll change that for now. So that we can work on with all the courses. So this will be course client, find course client, fetch all courses. Right, so there we go. So here we are retrieving all the courses. It's going out to that query, right? And it's fetching the database, the courses from that database, right? That we just updated, CS5610, right? So again, any changes that I make to the database, we should be able to see that here, right? If I edit this and say, web dev, and I update it, right? I can, if I refresh, notice that those changes are now available, right? Right from within my my dashboard, right? So the dashboard is displaying content from my database. Okay. All right. So I'm retrieving that. Uh, let's make sure that the delete and the edit still work, right? Now I did mention that our API, right, that is talking to these uh, to the server, right, to make sure that they take into account the fact that we are logged in, right? And to do that, this Axios, right? Axios, by default, if you remember, Axios does not pass in the cookies, right? We need to make sure that we have a version of Axios that participates in the session, right? So that we can remember that folks are logged in and whatnot, right? Axios, all by itself does not, right? So we're going to implement an Axios with credentials, right? That turns on the credentials, and then use this version, right, on all our queries. Now that what that means is that now the cookie is going to be passed along with every query, right? And so the backend, right, can retrieve from the session the current user, right, and use that in the logic. For instance, we want to do that when we create a course. We would also want to enroll the person into that course, right? And so for that, we'll need the session. Excellent. Okay. All right, so let's try out all the other queries, being able to say remove a course. Let's try that out. Right, it is going to go delete, with the course API courses and the ID, and that should go out to right here, right? So this should remove it from the database. So let's try it, right? So let's see if it breaks. So let's refresh. We got the courses, right? Let's say remove this one. Let's clue this out, see if that delete is going out to the server and the server is okay with it. So let's click it. Okay, so it went out, right, to the database. We just removed that. If we refresh, we should not see it. Let's see if that's true. Okay, perfect. So it is removing it permanently from the database. Notice that we didn't have to do much from the client's point of view, right? From the user interface point of view, as since most of our changes just happen on the server, right? We just switched over from talking to a database as opposed to talking to a file system. How about editing? Let's see if that works. Let's edit physical chemistry. So edit. We'll say 3, 2, 1, and we'll do a save. Let's see. Okay, so save. Let's see. It went out as a put, right? RS106, right? And the payload was that the new fields, the the new name, right? The name change is 3, 2, 1. And so that should have taken effect. So let's refresh. And there it is. So 3, 2, 1. Let's confirm this. If we go out to a database, we should see that physical chemistry. If you refresh, notice there's one less record than before because we've removed one record. And physical chemistry is now, the name has been modified. So yeah, actually we are able to interact with this single data structure of courses directly from the user interface directly to the database, always going through the pass through of the server, right? The routes and the schema and the model and the DEOs and whatnot. Okay, everybody good? Make sense? All right. Okay, so all right, so that's one that's you're dealing with a single data structure, right? So now let's go a little further and take a look at implementing modules, right? So modules, right? When we navigate to a course, right, and we want to add a new module, right? We want to make sure that that module belongs to this particular course, right? And 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 the way we can do that is that we have several options, right, to create this one-to-many relationship, right? One course has many modules, right? There it is, 1, 2, 3. There's a whole bunch of modules, right? Um, and um, and so there's several ways of implementing it, and the book describes it a bit, right? So if we scroll down to we have the discussion on implementing one-to-many. Here we have. So for instance, the graphical representation of the idea is that you have, one course is related to many modules, and the way you capture that in UML is that you have each one of these boxes represents the different data structures or collections or tables, right? And then you have these ordinals, right, that tell you how many of each instance is associated to how many in the other collection, right? So star means, zero or more, right? One course can have zero or more modules, right? And notice that, one common way to talk about this is that there's a parent-child relationship, right? Um, one course is the parent of many modules that are the children. That's one way to think about it. Or there's also could have an has a relationship where, one course can have many modules, right? There's the has a, right? A course has a or has many modules. Now to implement this, there's several strategies, right? The easiest strategy that is very common in a relational database, right, and is the most common way to implement it, is that the on the many side, right, the modules, right, you implement it using, adding a field that we refer to as a foreign key, right? And so in this case, it would be this course ID. So this course ID has the value of the course that this module belongs to, right? The value has a primary key and says it's referencing or it's pointing to, right, to the course that it belongs to. And so presumably you would have many module records, all of them with the same course ID, saying that all these modules belong to that course, right? So that's the easiest way to implement it, and this can be implemented in both a relational database and a non-relational database, right? Although this is a very relational database kind of solution, right? So you would not see much this implementation in a non-relational database, right? Although we are going to take this solution as, to implement, since it's the easiest to implement, right? Another way to implement this, but this is only in a non-relational database, right, is that instead you can have the parent, right, on the many side, for instance, the courses, each record have an array, right, of all the primary keys. So this would be like an array of foreign keys, right? So you can't do that in a relational database, but you can do that in a non-relational database. You can have it, the property just could be an array, right? So in this case, you have a property called module ID or module IDs, right? That has an array of the foreign keys, right? Or the IDs of the modules that belong to that course, right? So that's another way to implement it. The now one reason why you would not do this, right, is that if you need to remove, say you need to remove a module, right? So you'll need to do a delete on the module record, right? But then you will also need to come to the courses, right, and make sure to remove the ID from the module that you just removed, okay? If you delete the whole module. So that means that you have two updates, right? You have to do an update on the modules table or collection, and you also have to make a modification on the courses. So that means that, I mean, it's not that you can't do that, right? But you're adding an extra layer of complexity. You'd have to do it instead of a transaction, right? That, to make sure that both things happen, right? That that you're not that the server doesn't crash in the middle of removing a module, right? But then not removing the module ID, right? That would be unfortunate, right? It would be an inconsistency. So you make sure that you have to have it inside of a transaction. But a lot of these are topics that you would cover in a database course, right? So I'm sure you're familiar with this. The other alternative in a non-relational database like Mongo is that you just don't use the modules at all, right? You don't have a separate modules collection. Instead, right, the courses, each field, each record has a module array that contains, entirely the instances of the modules for that course. Okay, and so you would have, all the fields of the core of the modules inside of the module array instead of a course, right? And this is perfect, right? There's no need to have a separate collection to maintain. You don't have to have any references, right? And if you remove the course, boom, all the modules go away with it, right? As opposed to here, right? If you say you remove the course in here, then you have to go and remove all the modules that reference that course, right? Well, it depends on your implementation, right? But here, no, right? If you remove the course, boom, all the modules are gone. Now, it depends. Maybe you do want that, maybe you don't, right? Because it could be that the modules is shared across several courses, right? If you have a module, like an introductory module or a particular exam that is used across multiple courses, then this would not work, right? Because then you would have to replicate that same module and copy it into multiple courses, right? And one thing that we do hate in databases is redundancy, right? We don't want to have any redundancy because that breeds inconsistencies. So if you have that requirement, right, that where the module needs to be shared across multiple courses, then this implementation would not work, right? It would be better to have it outside here. Also, if your operations need the list of all the modules somehow, right, and I want to be able to treat the modules as one big list of modules, then this won't work either, right? Because you would have to iterate over all the courses, collecting and aggregating all the modules from the different courses, right? It would be very, very burdensome, right? Not something common here, right? It is. I don't know that we would need an operation where we would need to list all the modules. That would make no sense, right? So probably this would have been a really good implementation, right? But again, add some complexity. So we're going to go with a trivial implementation, which is this. Okay. So yeah, so we're gonna do that. So let's see. Let's see what we have so far for the module implementation. Okay, let's see. So for the database, for the server, we have courses, enrollments, users. Oh, we have no modules whatsoever. So we didn't implement, we didn't have any implementation in the prior lecture. So let's implement that here, right? So let's implement here a folder, we call it modules. Right, so the question is, well, where are we getting the modules in the application, right? So I mean, we're here and we see modules. So why do we see all of these modules? Probably all these modules are living on the client side. Notice that nowhere are we fetching these modules from the server at all, right? So all this data probably is within the reducers, right? And we'll fix that in a minute. So all right, so let's see. So we'll need a schema, right, for the modules. So we'll need a schema. Oops. And so this is going to um, uh, connect to a collection called modules that actually doesn't exist yet in the database, right? So let's do that. And the records in there are supposed to have primary key that has a call ID with the name of the module, the description of the modules, and whatnot. All right. We'll talk about that in a second. Okay, actually, no, this is the reference. This is the foreign key, right? That says that this is going to be holding the ID of the course that this module belongs to, right? And so it is a string. It is a string, and then notice that here has a field called ref, right? Ref. The value of this ref, if you'll notice, it's the same name that we use for the model when we declared the model, right? The name of the model, here it is, course model matches this name over here. And that's very important, right? Because this is going to allow us to do some operations that look very much like join operations, right, in a relational database, right? Even though non-relational databases don't support join operations, right? But this ref here, right, it's the Mongoose library, right, is going to implement something that looks like a join, right? Because oftentimes we're going to want to join data from the modules and data from the course, right, and collate it into a single record, right? So that's what it's going to allow us to do, right? So anyway, so let's import, right? We did not import the modules here, so let's create a new collection called modules, and we're going to import, right? right, from our front end, right, the database in our front end, there's our modules, right, that has the primary key M101, right, the name, the description, even has an embedded list of lessons, right, and there we go. So let's import this. Import, there we have it. Okay, perfect. We even have the array of lessons in there. Perfect. Okay. All right, so we have the schema. The schema, we have the ID, name, description, and course. So ID, name, description, and course. We could even add the lessons in here. That is an array of, let's see, the array that has a ID. We have ID, which is a string. We have the name of the lesson, oops, name. We have the description, which is a string. Can't type today. Let's remove all this. And the module belongs to, well, we don't need the module because I know that I'm inside the array already. So I'm already embedded in the array, right? So I don't need to have a reference out. Description. Okay, that's it. Okay, so notice that yeah, this is what non-relational databases is great at, right? Where you can embed data inside of the schema, right? And describe that this is, you know, arbitrarily complex, right? You know, not data types, right? That are not just primitive data types. You don't just have just strings and numbers and whatnot, but instead you can have other objects, right, embedded inside, right? Which is great. Okay, so we have the schema. We'll need the model, say model JS. So we'll need to import the mongoose, and we'll need to import the schema and the model, and we'll export that. Perfect. Okay, and then we'll need the DAO. We'll need DAO.js. Let's see if I already have that in my assignment. DAO. Okay, so we'll have find modules for course. Right, so the find modules for course, right, in a prior assignment, you might have implemented it. So we have the DAO here. So we'll import the model, right, which allows us to interact with the database. And so here this is where, right, the foreign key of course comes in and allows us to filter, right, and say, oh look, I know what the course that I'm in course RS 101, right? So I can tell the database, it says, hey, go and fetch me the data from that you know, from that collection, right, that whose course is equal to the ID that I'm giving you, right? And then we'll need the route. I think, do we have the route here? Routes. Now this routes, and this is a preference choice, right? That of how is that you might want to implement this. Now notice that the route, you know, I'm going to implement it in the courses routes, and you might say, well, maybe I would prefer to implement it in the modules routes, right? Because what am I retrieving? I'm retrieving modules, right? So theoretically, I would say, well, I want it to be implemented here in the modules, and that's totally fine if you want to implement it there. I'm going to implement it in the route, in the courses routes, and my reasoning for this, right, is that the API is going to start with /API/courses, right? And notice that all these APIs, they all start with /API/courses, right? So for me, you know, the fact that you're asking for the modules is just that you're asking for something that belongs inside of a course. Right? You know, I'm giving you the course. You know, for this particular course, I'm asking you for the modules for that course. So I am identifying the course, and then I'm asking the modules within that course, right? So, you know, that's how my logic works, right? Notice that the URL, you know, progressively starts with something that is higher level courses, right? And then goes into more details, right? Goes into something that belongs inside of the module of the courses, right? So modules, lives inside of courses. So that's how I thought about it. So that's what I'm sticking to that. But again, if you prefer to implement it inside of the modules routes, go ahead, right? So anyway, so I'm going to put it in here. Oops, I'm going to import the modules DAO, right, which you just implemented, and then right, I'm going to load up implement the find me the modules for this course, right? So there it is. So here's app get the courses. This is all the courses. But if I say, hey, if I give you the ID of that course, then I've identified the course. But then I don't want the course. I want the modules for that course, right? And that's going to use modules DAO, find modules for course. Perfect. Okay. Once I have that, we can go back to the courses client, right, and retrieve the modules for that course. So let's do that. Let's retrieve that. Go here, and then go back to the client, right, in the courses here, right, and then implement it here, right there. So find modules for course. Again, you would be tempted to have that live inside of modules and have a client for that, right? And that's totally fine, right? If it makes more sense to you, go ahead, go ahead. It makes more sense to me that it lives on the courses client, again, because all the APIs start off with courses API, courses API, courses API, right? And so for me, logically, it belongs here. Okay. All right. So once I have that, the modules, I believe, right now, okay, is retrieving all the data from the database, right? Well, maybe not. Let's see, modules, list modules. Where am I getting my modules? Okay, so from the, all right, yeah, from a reducer. There it is. So here's the reducer, and the reducer is getting the data. If I go to the modules reducer, it's getting it from the database. There it is. See that? That's where it's getting it from. Okay. So, but instead, we want the data to come from the server, right? When I navigate to the modules screen or the home screen, I want to see the modules be populated from the server, right? So let's see that, right? So let's make sure that the API first works, right? So here is the courses. Right now, if I give you the ID of the course, right, and then I ask for modules, there we go, right? These are the modules for course RS101. So it's working, and it's coming from the database, I believe, right? Notice that if I say RS102, I get a different set of courses, right? M201. And let's confirm that indeed this is coming from the database. So let's make this a little bigger so you can read this. So yeah, so fundamental from aerodynamics, that should come from the database. Let's confirm that. So let's see. M201. So M201, 201. Here, fundamental from there. So let's change this. Let's change this a little bit. 3, 2, 1. Let's update. Let's refresh and confirm that indeed this is coming from the database. Perfect. Okay. So anyway, so I want to be able to make this query, right, using what the client looks like here, right? This is what the client does, right? It's saying course API, course ID, modules, right here, right? Course API, courses are the ID and the modules. Perfect. So I want to do that from when I navigate to the modules right here. Right. So on load, I want to fetch all those modules, right? So let me grab the client function that I just created right here in the courses API, this function, right? So let's do that. Let's import the clients. We'll say import star as course client. Is that where it is? Yes. Okay. And unload, right? I want to do a fetch modules. Okay. Let's see if my AI works. Let's see, modules, blah, 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 await, courses client, fetch. No, this is called find modules for course, and we'll pass the CID. Okay. And then, yes, I would like to dispatch it. So I have the CID. I would like to dispatch it and then populate these modules. I want to send them over to the reducer so that it populates this data that came from the server. I'm going to populate the reducer with this data so that I can remove entirely my reducer, right? I want to go back to my modules reducer and say, no, I don't want the database. I don't want the database. I want to start this empty. No, no modules, right? So here, right, if I go Ada 1, 2, 3, and I navigate, right, notice that there are no modules, right? There are no modules. Those modules have to come from the server, right? And that's exactly what we're doing here. I'm going to go out to the server, and I need to, now that I have the modules, I need to send it over to the reducer. So the reducer, somehow I need to pass that data. So what I'm doing is I'm going to create a function that is going to allow me to initialize the state, right? So set modules. I'm going to send in the modules and say, so and then I'm going to populate. I would say state.modules is the modules that I'm going to pass you, right? And I'm going to export this, right? So that from my modules, I can import from the reducer my set modules, right? So that now I can dispatch to here. I can say your dispatch set modules. See that? And when do I want to do this? I want to do this on load. So use effects, right? Use effect. I want to invoke my fetch modules. You know, whenever my course ID changes for different course ID, I want to fetch different modules, right? So let's try that, right? Let's clear that out and do Ada 1, 2, 3, sign in. Okay, there we go. Let's clear this. I'm going to click on this, and there we have it, right? These are the 3 modules for this particular course, right? The query went out. There it is. So this is the same query, right? RS101 modules that I was doing here when I was trying it out, right? There is RS101 modules is exactly the same information that we're getting here, right? The response is those array, and that's what's being, I'm populating the reducer with the data from the server, right? Making sure that the data in the database, matches the database in my user interface, right? If I go to a different course, hopefully I go to aerodynamics, it'll be a different set of modules, right? Again, a different query, right? That goes out to RS102, different set of modules, right? And the response is a different set of modules for that particular course. Make sense, right?
I
So
have a
yeah,
question.
I'm sorry.
I have a question. Like
Yes.
if we are fetching the state from database, so do we still need Redux for this?
So Redux is only so that you can maintain state on the client. If you need to share this state amongst several screens. So for instance, we know that the modules and the home screen are sharing the same set of modules. So we don't want each one having to fetch their own set of modules, right? So instead, what we do is that we put it in a cache where it can be shared across multiple screens, right? So that's the purpose of the reducer, right? Maintaining state, right, that is going to be shared across many screens. Now, if it weren't shared amongst multiple screens, then no, the reducer would not be needed, right? If it's only maintained in one single screen and nowhere else, right, then yes, it would be totally fine to just use plain old, use state, right, use effect, right, and then have a client that goes and fetches the data and it populates the state variables of that one component, right, because it's not being shared across anyone else. Make sense?
Okay, yeah, got it. Thank you.
Yes. All right. Now obviously we would need to implement all the other operations of creating new modules, deleting a module, updating a module. But that I'm gonna leave it up for you, right? We got you going, right? Of creating the API on the server, right? And then hooking it up to the client, and then populating the state, right, of the modules for the reducer. Okay. So yeah, so yeah, the assignment walks you through implementing all the other CRUD operations for manipulating the modules, right? We just looked at retrieving the modules for a particular course. Certainly, we need to be able to edit the modules or delete the module and things like that, right? So yeah, so work on that. Let's take a short break, right? And when we come back, right, we'll discuss many-to-many. Okay, I'll be right back. Don't go anywhere. All right, let's continue. Okay, so right, so we discussed how to implement several types of data structures, right, in a database, right? We discussed how to implement just single collections, and also how to implement a simple relationship, right, between one record, right, that might be associated to many other records, right, a one-to-many relationship. Now let's discuss another very common way to split up data is to use a many-to-many relationship, right? And we'll use as an example the enrollments, right, of many users being enrolled in many courses. Okay, and so for instance, you would have many users related somehow to many courses through an enrollments, right? Now, if you don't have to specify the type of this of relationship, right? Then perhaps it's enough to capture it this way in a UML diagram, right? You just have star and star on either side, the cardinality of many on one side and the cardinality of many on the other side, right? And this is understood that you can have zero or more users associated or related to zero or more courses, right? Now, this is a little bit too abstract to actually implement this, right? Typically, in a relational database, the way you implement it is you reify or you convert it into an equivalent representation. And commonly, the way you do this is by adding in between an association class, or sometimes referred to as a mapping table or mapping class that is implemented by having primary keys, right, in this new table, right, that has references to either one of the original collections or tables. Right? So, for instance, the implementation would be that this new enrollments collection has primary key, foreign keys to users and foreign keys to courses, right? And so that the a new instance of an enrollment says that this user is enrolled in that course, right? And if the user is enrolled in multiple courses, then you have multiple records, right? But the same user, but pointing to different courses, and vice versa, right? If you have one course that has many users enrolled in it, right? You would have the same course ID, but many different user IDs in multiple different enrollment records, right? So this is the most common implementation in relational databases, or even what we're going to be doing. Another implementation that is we're not going to take a look at, but it could have been an alternative. Could be that users this implementation is actually very doable in a non-relational database such as MongoDB. This could be implemented by an array of users, right? Having an array of courses, right? That have an array of foreign keys of all the courses, right? That user is enrolled in, and same thing for the courses, right? You would have each record or collection, document in the courses have a field called students, right, or of the students that are enrolled in that course. Okay? And that'd be totally fine, right? The only caveat to that implementation is that, say you need to unenroll somebody from this course, right? So that means you would need to do two updates, right? You need to remove from the user's document in the array, you have to remove the ID of the course that this user used to be enrolled in and no longer is enrolled in. And then also you need to update the array in the courses, right? Because in the enrollments array of the, or the students array in the course, you have that user ID listed in that array. You have to remove it from there too. Right? So for instance, it would be inconsistent, right, to remove it from one array but not the other, or vice versa, right? It would be inconsistent. So you do need to remove from both. So and usually you want to avoid, right, database manipulations where you are that requires two updates, right, to two different collections or two different tables, right? Obviously you would have to put this inside of a transaction, right? So yeah, so that's the only caveat, but absolutely doable. What you can also implement would be users where you have an array of embedded courses. I think that would make no sense, right? Because if you have the whole record of the courses, embedded inside of an array inside of a particular user, well, but then you're going to have some other user being enrolled in the same course. So you would have the same course copied multiple times, the entire document, right? So that would make no sense, right? To have an array of embedded courses inside, right? So that's out of the question. But so what we're going to do is that we're going to use the most trivial implementation, which is a mapping table in between. Our case is mapping a collection that's going to have a reference to the course and the user, right, that are enrolled, right, that the user is enrolled in that course. Okay, so let's do that. So let's see. We'll need to for this, we'll need to remind ourselves that we did give a name to the models that we are now relating to one another, right? We name the courses, we call the course model, and the user, I think we call a user model. Let's confirm this in the users in the model. We called it, yeah, user model, right? And in the course. In the model, we call it course model. Perfect, right? So we're going to create enrollments. Right now, the DAO is just just accessing the database. We don't want that anymore. So we'll need to replace this database file with working with the database, right? So first let's in the database we'll create a enrollments collection. So this will be enrollments. And we're going to import data from our front end enrollments. Let's see, we have here that all these users are enrolled in these courses. Perfect. So let's do that. Say, yep, there we go. So we have a couple of enrollments in there. Excellent. So yeah, so these are are going to be treated like foreign keys, right? This user 123 is enrolled in course RS101, meaning so this user 123 Alice, right, is enrolled in course RS101, which is rocket propulsion. Okay. All right. So now we need a schema over here. We'll create a schema. So schema JS, and I'll just copy it from my cheat sheet from the assignment. We already have the schema, so let's copy that and let's discuss this. Okay. So let's see. So we have here the enrollment schema. We have the two foreign keys. These are the two foreign keys from saying, hey, the course and the user that are related in this association are this particular course and this particular user. Notice that the values are strings. So these values must be the values, the data type of the primary keys of each one of the associated documents, right? So here the ID is indeed a string, and the ID for the course is also a string. So that matches. Perfect. These two are strings. Perfect. The other thing is that the refs need to match the name of the model that we gave them. So course model needs to match course model, right? Word for word, right? And then user model needs to match the name of the model that we gave it, user model, right? So this is going to be useful for, again, for implementing a join, right? And so we're going to demonstrate how to use joins, right? How to implement joins. Not the database. The database is not going to be doing joins because relational databases don't support joins. Instead, right, it's Mongoose, the library, right, at the application level, right? We are the application layer implements, right, something that looks very much like a join, right? It has a different name. It's called populate, right? But it is the same operation of picking out some data from one collection and merging it with data that is from some other collection, right? That's what a join does, right? Wherever the foreign key and primary key match. Okay. There's some other stuff in here, grade, letters, yeah, we're not going to worry about that. And the collection is enrollments, right? So it is tied to this particular collection. Excellent. Okay. Now in the let's create the model. So model. So we'll need to import Mongoose. We'll need to import the schema and the model is the enrollment model, schema, and the default. Perfect. Okay. And so then in the DAO, let's implement some trivial things. Okay. So for instance, some of the simple CRUD operations, like for instance, retrieving all the enrollments. So let's do that, right? So let's see, export function, find all enrollments, right? And we're gonna use the model for this. So let's import the model, right? And so we're not gonna use the database here. So we're gonna say, I'm gonna do export. This is async, right? And then we're gonna do const enrollments, await, find model, perfect, and we'll return enrollments, perfect. And then we'll create a route here. So routes JS, and this will be, let's see, we're going to import the star as enrollment DAO from the DAO, right? We'll export const enrollment routes router, right? And then we'll do const find all enrollments, right? And we're going to do this is going to be async. So it's async, and we're going to do const enrollments. We're going to return all the enrollments, and we're going to map this to app.get API enrollments. So this is going to return all the enrollments. Perfect. Okay, so something really, really trivial. And then let's, in my index, we're going to bring in my new router. So this will be import enrollment routes. There we go. Oh, we didn't export it here. So export, export, can I say export default here? Oh, if I declare as a function, I can, right? Function. Then I can just import it without this. Perfect. And we're going to add app. Perfect. All right, so let's try it out. So I should be able to go to API enrollments and enrollments. If I could spell this, enrollments. There we go. So we have all the enrollments. Everybody good? Okay. Perfect. So then now the enrollments, notice that the IDs, right? See this IDs? These IDs, I mean, 1, 2, 3 and RS101 it's not very useful to me, right? Ideally, right, those IDs would actually be the objects that they actually belong to, right? The actual object user and the actual course, right, for the RS101, right? I would like to join, right, 3 tables or 3 collections. The enrollments collection that we have here, join it, right, with the users collection that has all the user information. You bring that over, and merge it with this data retrieval. Also merge it from, or join it with all the records, right, for the course whose ID right, matches this foreign key, right? This matches the primary key that for the particular course, right? And so that would be a merging or a joining of three different collections into one single select statement or one single retrieval, right? Now to do that, right? What we could do is that find all enrollments here. Um, we can do the following. We say model.find, right? And then you can say dot populate user and course. See that? So what that does is that it's going to join. It's going to say, hey, bring all the information from the user, right? So this is the field user, this field over here, right? This user field, which is a foreign key, right? So populate it. I don't want the ID of user. I want you to populate it, meaning join it, right, with the model that it refers to. It refers to user model, which is the user table as a user schema. Bring all that information that matches this foreign key with that primary key, bring in that instance, and then replace, right? Replace the courses field with the actual object that matches, right? Now, if I go here and I refresh, look at this. The user object or the user field no longer contains just the primary key, but it contains the actual data from the user collection. And course right now contains the data from the courses collection. See that? I mean, that is a join, right? But notice that this is not being done at the database level, right? This is being done at the application level, right? It is the Mongoose library who is doing this, right? It's going out to the database again, right? When it finds the user ID and you're asking it to populate it, it says, ah, okay, well, I know that I'm using the model, user model. I know the ID. I can go and fetch the the um the document whose primary key is 123, fetch that and then populate this and replace the ID with the actual object. That's pretty cool, right? And then same thing for course, right? I know that it is the model for the courses model, right? I know the ID, RS101. I'm going to do a find by primary key, and then I'll retrieve the course and then just replace it and populate it in there. Obviously, this is much more expensive. That is very expensive, right? Because it needs to go out to the database several times, right, to fill in all these things, right? So you should use this sparingly, right, and not just willy-nilly all the enrollments. Maybe particular, if you go to a particular enrollment, maybe that's what you want to do. Okay, so I'm going to remove that from here because it's not something you would normally do, right? So I'm just going to go back to my normal thing here. Okay. Okay. Uh, now, now the this is a many-to-many relationship. So that means that for a given user, right, one user might be enrolled in many courses, right? And so oftentimes I would like to be able to answer the question, okay, well, if I give you the user, can you tell me all the courses that this user is enrolled in, right? Like for instance, if I'm a student, I go to my dashboard, I want to see all the courses that I'm enrolled in. That's a legitimate question, right? But then the inverse question is also valid. If I give you a course, right, can you tell me all the students that are enrolled in that course, right? So for instance, if you go to the people's table, right, the users table inside of a course, right, it'll give you all the students, not including you, right, that are enrolled in that course, right? So that's a legitimate question, right? You want to see this in two different directions, from the user's point of view and then from the course's point of view, right? Because again, it's a many-to-many, right? It's bi-directional, okay? We would like to implement something like that. I would like to, for instance, in the DAR, I like to ask export, right? Async, find enrollments for user, meaning I'm going to give you the user, give me all the enrollments, okay? And vice versa, right? If I give you the course, right, give me all the enrollments for that course. And notice that here, it does make sense to populate, right? So notice that I'm going to say, model.find users, blah, 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 course. Here's the enrollments, and give me all the enrollments where the course populated. Okay. And so that if I'm going to, as a user, and I go to my dashboard, I know who I am, the ID, right? Give me all the courses that I'm enrolled in, and then I can populate the dashboard. I mean, but then if I go into the people's table, right, and I know the course ID that I'm in, right? So okay, well then just find me all the enrollments, all the that where you have for this particular course, right? And then but then populate the user because I want to display all the first name and last names in that table. You see that, right? Okay, so so now that we have that in the DAO, let's look at the route, right? And so we want to and now implement same thing, right? Const find enrollments for users. So presumably you'll give me the ID and I'll use the enrollments DAO find enrollments for user and return the enrollments, and same thing for the courses, right? And let's create APIs for this. Um, Actually find enrollments. So enrollments for user, meaning I have the user, I want to know what the courses are. So a better API, I think, would be that you would give me the user, and then I would see the enrollments like that. So I think it's a nicer URL, right? You start off with the knowing the user, and then tell me the enrollments, and then or if you start from course and you give me the idea of the course, right? And I want to know the enrollments for that course, right? All right, so let's try it out. So let's see if we go back here and I go if I say users and I say 1, 2, 3, I want the enrollments. Enrollments. Did I spell it wrong? Oh, users, I think, and courses. There we go. All right, so 1, 2, 3. I think this is I forget who the user is. I think it's who's the user? Is that Ironman? Right. So he's enrolled in rocket propulsion, right, and also enrolled in aerodynamics, right. And if I have 2, 3, 4 is enrolled in the same thing, and 3, 4, 5, right, is only enrolled in rocket propulsion. Let's see who we have here. This one is enrolled in that. Okay. Now I want to do it the other way around. I want to say courses, right? And I say RS 101, and I say I want to know the enrollments. There we go. So I see that all these users are enrolled, right? Ironman is enrolled. ID2 user enrolled. I guess I have some records in there for a user. Oh wait, what? So I have course RS101. I have some enrollments in there that don't match course, and then there's no user. Interesting. Oh, or maybe the IDs don't match. Maybe I have some weird IDs in my database that don't match. RS101. Okay, so enrollments 1, 2, 3, 2, 3, 4. So RS101. Okay, we have 5, 6, 7, 5, 4, 5, 6. So these users don't exist. 1, 2, 3, 1, 2, 3. Alice is 1, 2, 3. Oh, I have. Oh, the IDs are weird. 1, 2, 3. Oh, see, the IDs don't match. So, and some of them have some really weird IDs. Okay, so we would have to fix this, right? So, the enrollment, so it can't find those particular users, which is fine, right? All right. So, now notice that this is returning the enrollments objects, which is fine, right? We do, which is, uh, but notice that there's not much information here other than the user. There's not much useful information, right? We have the status, we have the ID, the course, and maybe if we have other additional information like maybe the grade that you got, things like that. But sometimes it's just is useful, right, to just have the courses or the users, right? So an API here, instead of find enrollments, right? Maybe it might be useful saying const find courses for user, right? Which I think. And, so it's the same API, right? Find course, so find enrollments, I find the enrollment, so I grab the enrollments. Now what I can do is that I can iterate, I can map the enrollments and just extract the course. And once I have the course, I just return the courses. See that? And same thing for here, right? I want to do const find students or users, for course, right? So same thing. I first find the enrollments like I did before, but I'm just going to extract what the users are, right? And so the APIs might look a little bit different. It might be that they look almost like this, but then user ID, and this is courses, and this is courses, and then users. So find courses for users and find users for course, right? So now if I go back here, right, and now I go from courses, I want the users. There it is, right? I just have the users. Now I might want to filter the null, right? Maybe um, so yeah, so enrollment, blah blah blah, map. So enrollments, map enrollment. So I want to maybe filter. It says dot. So this is what retrieving the users, retrieving it. So find users courses, find users for course. So this one we might want to filter out. So it's filter. So enrollment and filter enrollment E, where E dot user is not null. There we go. So we filter out the ones that are null, right? And now vice versa, right? We say users, and then 1, 2, 3, and then say courses, and there we go. We just have the courses. So this is very useful, right? To be used maybe in the dashboard, right? Or maybe the people table. We can retrieve these things. Okay. The other thing that we want to do is be able to not only answer these questions of who's enrolled in what, but also enroll people, right? Um, so for instance, how do we do that, right? So for instance, in our DAO, I want to be able to create a new enrollment, right? And create an association. So for instance, I might want to say, export async, enroll user in course, right? So I am going to give you the ID of the user and the course ID. So we'll have a new enrollment will be a unique ID, and then the user will be the user ID, and the course will be course ID, and we'll insert this new enrollment, and then I'll return the enrollment. And now also, if I want to remove the enrollment, well, to remove the enrollment, it could be two ways, right? I could give you the IDs of both the user and the course who I want to unenroll, right? And then I can delete it by user. If the user matches the user ID and the course matches the course ID, I want to remove that one record, right, and return the status. Enroll. Okay, excellent. So to expose this as a route, right, that I want to create a new enrollment, because I'm creating new data and I'm inserting it, typically it will be by a post, right? So it will be const enroll user in course. Yep, we're going to encode the user ID and the course ID in the URL. We will call the enroll user in course, passing the user ID, and okay, yep, perfect. my AI. And so here it is. So delete for unenrollment. So this would be unenroll user from course. Is that how we called it? Oh, delete enrollment. Okay, no, I think a better name for that is unenroll. So enroll user in course, unenroll user from course. Yep, that's a better name. There we go. So unenroll user from course. And this all exists, right? So then now for this one, because we're creating new data we're inserting into the data set, right? We're going to do a post, right? And when we encode users, user ID, right? And then courses, course ID, and then delete will do the removal from the user from that particular course. Perfect, right? And And so yeah, so now obviously we need to integrate this with the user interface, right? When we either create a course or from the enrollments table, right, where we have a list of all the courses, right, that a user might enroll in that course, right? But that I will leave it to you, right? So this is the server side, right, of the enrollments part, implementing the many-to-many relationship between users and courses. Okay. All right. Let's take a very short break and then we'll jump into office hours. Okay. Don't go anywhere.